In other words, you definitely don't want to be less than a half. So it's okay to be a little bigger than you're small. But anyway. So that's got that. And we're going to use red. So I've seen a very small number of these gears, and I've already looked at it, but I didn't mention it, that the gear is actually inside here a little bit too shallow, so the washer bottoms out on the crank instead of the gear. So you always want to feel it and just make sure that it's, you know, it's just a little bit below.
Good tip. See, that's just the type of shit, you know, you can unbox top end parts all day long and just bolt them on, but it's that stuff that's
The little stuff.
cumulative knowledge.
All right, a couple ways you can do it. If you don't have one of those, take your belt, piece of leather, real heavy piece of leather, and put it in there. That's fine. All right, I'm gonna hang on to that. All right, and here we go. Fine. You'll probably have to flip the wrench around.
That's right.
Yeah. It's a bugger to get it on there one way. It'll go, it's just finding that right spot. Got it?
Yes, sir.
Okay. Gear alignment, and that looks fantastic. Perfect. The other thing I like to look at, one of the reasons I do that, put just the light film, is I'm watching how the lube tracks. Just like setting up a rear end in a car.
Sure.
All right, and if I saw like just one spot that it wasn't really hitting all that great, then I may want to look at something. But
It's right down the center.
it's right down the center all the way. And we're golden. And you'll notice.
Nice and quiet, tightened up.
Yeah. All right, I'll leave that the way that it is. All right.
You didn't hone these at all, right? These are just this.
Correct.
They feel great, so.
All right, so we'll start with the standard. You got just a little bit of shake to it.
A little tighter.
A little more shake. These actually feel really good. I'm gonna let you do it too. Actually, too tight.
Is that a half thou
Too tight.
over?
This is a 1
A
thou.
1.
All right, that's a little too tight. All right, because when you machine the rollers, you do the other machining processes, it'll grow like a tenth or two, right? I mean, we're talking such a small amount here. But if you were to do this with no shake to it at all, yes, you could physically put the tappet in there, and you would, you know, like you'd have a little bit of stiction. You kind of have to force it down. There's no need to do that.
A little room for thermal expansion.
Yeah, see, there's no shake to that one at all. A little bit on that one, so we'll probably run The one in that one. There's that one right there, so I'll let you try it. Let me grab. All right, so what, you tell me what numbers you think, and the reason I want to do this is then we're going to actually put the tappet in there, and that way you see the correlation.
Sure. Let me see what your thoughts are.
That's probably too tight.
Too tight.
That
So,
one will probably,
be a 1 then.
that one will probably get a 1.
Haven't done that one yet.
And what we'll do after a heat cycle. So Comedic's gaskets, an interesting thing. Their gaskets are engineered. It's not just like foam or paper. And they're designed to go on without any kind of sealants at all, actually. So they have this elastomer that's impregnated into that foamette, is what it's called. And even in their paper gaskets. So when you torque it down, it actually releases some of that stuff that acts as a sealer and seeps into pores like this stuff right here. But their metal gaskets, like the MLS gaskets and base gaskets, are coated with Viton. Well, it kind of does the same thing, and it still has a elastomer in it, right? So obviously, once we do a heat cycle, we go back through and we're retorque the cam cover before it goes. So basically, you run one heat cycle, and then when it cools down, you go back and retorque everything, and they'll never leak.
That's awesome.
It's a beautiful thing. There's a lot of engineering that goes into gaskets. Okay, so I wanted you to feel something actually. You know, you've heard me use the term stiction before.
Mm-hmm.
Take that one and push it down in there.
Yeah, I can see.
See how light it is? But remember, the oil is taking up a lot.
Right.
All right, so there's absolutely nothing wrong with that. All right, so we got that done. Now we're gonna check deck heights. I wanna make sure, show you that and go through the numbers. Again, you're gonna be doing this again. Now these are also very tight tolerances, all right? You never wanna, you gotta find that right spot to get it in there, all right? And when it starts, if that sucker sticks, stop. Because you can have a little burr on the edge that's just enough, and it'll drag it and scratch the heck out of it. So you just wanna make sure it's clean, and just real delicate slide in there, and it should walk its way right in. And you should have again, no slip fit, no shake. You're at about 1.5 thou clearance right there. It's got just a tiny, tiny amount.
Yeah. It's almost imperceivable, but still good movement.
Perfect. Some pistons, and a lot of folks don't understand the logic behind how pistons are marked. So a lot of manufacturers will try to make the same front and rear piston. All right, well, some pistons, like what we do, because you have thrust pressures as the crank's coming over center and it's pushing up. It's a 45-degree motor. It's a lot of pressure here and here. So we design ours with an offset wrist pin. Invariably, I've seen it. You always have to look for that, because it's not like you open an instruction sheet and it says, hey, this has an offset wrist pin. Well, they will physically fit and they'll physically go in. But after a couple thousand miles, if you're lucky, it will just absolutely shred one side of the cylinder and the piston. So if you look real close at the bore, see how it's offset.
Mm-hmm.
It's a little thinner on this side right here, right? Mm-hmm. Now, if the design has been done proper, these are our pistons that KB makes for us. If the design is done proper, it will always tell you which way it needs to face. It'll either say cam side, or it'll say front, or rear, or intake, or whatever the case may be, so you don't mix it up. The other thing is, on like our 4 5/8 stroke version of these, our scallops are a little bit different to allow room for the rod, but you'll notice these are the same, right? Okay, so these could technically go in. Of course, your intake valve's the biggest one, right? These could go in technically this way or this way physically and fit, and you would never know the difference. However, that offset wrist pin changes that, all right? So we put plug side to make it obvious. Plug and plug. So there's no way for you to get that wrong. Plug side, rear piston, intake facing forward. Plug side, intake, that's the front, all right? I absolutely love using spiral locks, but a lot of folks have a big problem installing spiral locks. And what they try to do is take this and then dig it into the piston and do it like that. I'm actually going to show this on the camera. So spiral lock like this, and they'll just try to dig it in there. The trick to doing these is you stretch them open, but you don't stretch them open too far, right? So you're going to stretch it just to the point like you can put your thumb and form a spiral, and anywhere you feel a little tight, just spread it open a little bit, and you want to be able to roll your thumb all the way around it to where it looks like that. Got it? All right. The other thing is I find it easier because I like to use band style ring compressors, and you fight with it over here. I like to do my final assembly from this side, okay, so I can have the ring compressor up and pop it in there. It's just easier for me to use it that way, okay? Because I want to not be in here, I'll go ahead and load it on this side, so I'm not trying to put it in afterwards. And I'll just do that. So, and then just walk it around with your thumb. And what I really like about them is when you're putting it in actually putting it in the engine, you're not fighting that stupid tool, and they don't go pew, you know, because it's on your thumb. And if you just take and just walk it around in a spiral, and that's how you do it. Witness mark right there where it's a little shiny. All right. Let's touch it right here.
Okay.
All right. So I'd already shaved that one down. All right. A lot of times, and this is manufacturing tolerances. This is things you have to look for. But these are the big race rods. All right. So they're not ground here. So, and this comes down to tolerance. This piston's off a little bit. That may be off a little bit on the top on the thickness right there. But sometimes when you put these together, you'll put it in there and you go to rock the piston and it'll feel real sticky, and sometimes you can't even get it to line up. All right, so we can see where it's touching. We can see the little polished edge right there. So we're going to go over to the mill and we're going to mill that off. That's all good. Perfect. These are those delays that people don't get to see. Mm-hmm. These are those, you know, the things you can't, you know, you can't really foresee, the things you can't really plan for.
Well, again, you know, to your point, you know, you're a lone wolf trying to do this at home in your shop, and you run into this. What do? You pound the damn thing on, or you know, start taking a file to your rocker or your lifter covers.
Yeah.
Try to make that clearance.
Yep. And because, yeah, and then you run to the point you have to make that decision. Well, where do you cut it from, right? Well, we know these are a lot more fragile than these. And when we compare the gasket, we still have plenty of sealing surface there. Mm-hmm. So we're gonna mill this side to the gasket. Hey, so what we're doing, we never actually said what we were doing for the camera. Did we? We never actually said. So when we slid the cylinder down, you know, the base of our cylinders here that Jim's makes for us, they're pretty big. So when we slid the cylinder down on top of the case, just this inside edge right here was hitting the tappet cover. So we had to go through here and clearance that just a little bit, but we're only clearancing it up to where the gasket sealing surface is. So we're gonna have plenty of room there. Well, let's call that 20 and a half, really, right?
Yep.
Well, let me go this way one more time. I think I must do this one with my hand. We're about 20 and a half.
Yeah, 20 and a half.
20 and a half. All right.